Hi everybody. Today we are going to be kind of throwing you for a loop. As you notice, this says topic 16 polynomials, and you're thinking we just did quadratics and haven't really done a whole lot. And if you are thinking there's got to be more to quadratics, you are absolutely correct. However, things are always fluid and ever changing. So in an effort to get you guys the best education while online, the state and district has decided to bring on this new Apex platform that I mentioned in Schoology. So not to worry about any of that. That'll all come in due time. But I do want to introduce you to polynomials because you're going to start off with polynomials in Apex. So we're going to take some notes today. I hope you guys are able to follow along. And if you have questions, obviously don't hesitate to ask. All right, so I'm going to actually change my color here. Okay, so let's first start with the definition of what a polynomial is. Okay, so polynomial is any expression of terms being added or subtracted. Okay, so we're going to put an expression. And if you guys notice, I'm using a different angle this time. Maybe it might be better. My hand won't get in the way of my writing. An expression of terms being added or subtracted. Now, okay, that's great, but we have a problem. What is a term? Okay, so a term, we defined it a long time ago, but let's talk about it again. Okay, a term is a single number or variable or a number and variable multiplied. Okay, so for example, what does that look like? All right, so if we had this, if we had 3 plus 2x, okay, these two things, these are the terms. Okay, this whole thing is a polynomial. All right, so we have this is a good, just the basic of it, okay? We are going to get into the types of polynomials that we can have. So there's 3 types of polynomials, okay? So let's do, whoops. Okay, so we have a monomial, do you guys miss the clicking pen? A binomial, and a trinomial. Now, these words should sound familiar, right? Monomial, monorail, single thing, right? One, this is one, right? Binomial, what's bi? Bi, think bicycle. Bicycle means 2, okay? And then if you're thinking 3, yep, tricycle, okay? There's 3. So let's look at some examples. So a monomial It could be just the number 2, or it could be a number times a variable, right? That's one term. A term, a single number or variable, or a number and variable multiplied, okay? A single number. You guys, this is called a constant. Remember, the number by itself is a constant. This is a term being multiplied, a number and a variable. Do you guys remember the name of this number? It starts with a C. It's a coefficient. Okay, this is a coefficient variable. The coefficient is what multiplies the variable. All right, so a binomial would be 2 terms, right? So we could have something like 4a, right? There's one single term, but we need 2 terms for a binomial. So 4a minus 2/3. This is a number, okay, right? A term is a single number or a variable. So those 2 terms make it a binomial. Or what if we had something different? 6x cubed minus 4x. 2 terms, okay? 2 terms, binomial. All right, a trinomial. Trinomial, what if we had something like this? 3x squared minus 4x plus 1. 3 terms, 1, 2, 3. Remember, terms, a single number or variable, or a number and variable multiplied, okay? They are separated by only plus or minus signs, okay? So that is polynomials, all right? Now, we need to talk about what is not a polynomial, okay? So we have 3 things, and I hope you guys are pausing as we go so that you can take the notes that you need. 3 things that make an expression. We'll say an expression, because there's no equal signs here. That make an expression not. That's really, this is big, okay? Not a polynomial. Polynomial. Okay, 3 things that make an expression not a polynomial. It can still be an expression, right? An expression is a mathematical sentence or an algebraic sentence without an equal sign. So it's still an expression, but it's not considered a polynomial if these 3 things happen, okay? So first thing, 1, if the variable if we have a variable as an exponent, what would that be? Do you guys remember? That's like 5 to the x. This is not a polynomial. 2, if we have a variable in the denominator, okay? If the variable is in the denominator, like 1 over 3 to the x, this is not a polynomial. The variable cannot be in the denominator, okay? And then the third thing, it's kind of a 2-parter. So the third thing is a variable. This is what makes it not a polynomial. A variable with a negative negative or fractional exponent. So two examples for this one, because there's two things. So a variable with a negative exponent would be something like 4a to the negative 2. Do you guys remember what happens with this? What happens when we have a negative exponent? Remember, drop it like it's hot, okay? So if this dropped down, it would be in the denominator, and then it wouldn't be meeting this criteria, right? If it's in the denominator, it's not a polynomial. So this is not a polynomial. The other one was a fractional exponent. So what if we had fractional exponent? What if we had just y to the 1/2? Okay, that is not a polynomial, because look, this is the same as square root of y. So anytime you see this radical sign, you're going to know that it's not a polynomial. Okay, so that radical sign is going to be like an indicator. All right, okay, let's move on to the next piece. We are going to talk about the degrees of polynomials. Okay, degrees of polynomials. Now this is not temperature. Okay, this is the degree, meaning the exponent. What's the exponent? Okay, so the degrees of polynomials, we're going to write, is determined by the exponent of the variable. Okay, it's determined by the exponent of the variable. For example, if we had 8x cubed, all right, 8x cubed, well, the degree, the exponent of the variable is a 3. Let's get that green working. Okay, so this 3, that 3 right there, okay, this makes it a 3rd degree polynomial. All right, do you guys remember what this is called? Remember? This is the coefficient. Okay, this guy right here is the coefficient. Okay, so the degree, remember, is the exponent. It's not the coefficient, it's the exponent. So we've got a 3rd degree polynomial. Let's look back up here. This is a 2nd degree polynomial. Okay, this is a 3rd degree polynomial. All right, and you're thinking, some of you may be thinking, well, what about that degree? That's a degree of 1. It wouldn't be called the 1st degree polynomial because you determine the polynomial by the largest degree. Okay, so if we had here's our whiteboard. If we had 5x to the 3rd plus 7x minus 13 minus x to the 5th, or let's make it to the 6th. Okay, this would be a 6th degree. All right, 6th degree, because it's the largest. It's the largest, okay? All right, So let's talk about this 13. What degree? This is a degree of 1, right? What's this degree? Because we know that the constant can be a term and a polynomial, but what's its degree? All right, so let's talk about that. Okay, so here's the question. Let's see. Okay, what is the degree of 13? Okay, to do this, we have to remember something. Here's us remembering. We have to remember what any number to the 0 power is. It's 1, remember? Remember when we did our calculator, you picked like a crazy number, 237, and you put it to the 0 power, and you got 1. And then you picked, I don't know, 346, and you did that to the 0 power, and you still got 1. So anything to the 0 power is 1. So if we have 13, okay, we could say that, what if we had 13x to the 0 power? Well, if we know that x to the 0 power is the same as 1, isn't this the same as saying 13 times 1? And we know from identity property of multiplication that 13 times 1, or any number times 1, is just going to give us that number that we started with. So this is all just 13. Okay, so what can we deduce from this? The degree of a constant is always what? Not 1. Remember, to get the 1, we had to raise it to the 0 power. So it's always 0. Okay, so back to this guy, right? We had 5x cubed plus 7x to the first. We may or may not have the 1 there. There's an x here, but because the x has a 0 power, we don't see it because it's just a 1. We can plug that in. We could rewrite this. We could rewrite this as 5x cubed, showing all the degrees, right? 7x to the first minus 13x to the 0 minus x to the 6th. We could do that. We could show all the degrees, and then we could see, oh, well, there's the 6. Now, would we write it this way? No, and it's not just because we have an x to the 0 and x to the first. We wouldn't write it that way because the proper way to write a polynomial is in descending order. So this would go first. Now keep in mind, it's got a negative with it, okay? So the proper way, right, would be negative x to the 6th. Which one's next? This is the next highest, right? Plus 5x cubed. That's the next term that we would want to put, okay? And then what term would be after that? So we did this one, we did this one. Next term would be 7x. And I'm going to leave off the 1 because we don't need it. And the last term would be this minus 13. Now, it is x to the 0, but x to the 0, remember, that's the same as saying 1. So 13 times 1 is 13. So this would be the polynomial. Okay? So in our notes, if you want that in your notes, that's a really good thing. You could put that here. But for our note purposes, we're going to write this. Polynomials must be written in descending order of degrees, or of degrees, I guess. The descending order of degrees. Okay, so what's that mean? Yeah, it's just what we just did, right? So we can make another example. We could say 4x squared plus 3x to the fourth minus 2 plus 7x cubed. Okay, we need to take this and turn it into the proper order. So the highest degree is going to be this 4, 3x to the fourth. What's next? We got an x squared, x to the 0, x cubed, that's next, plus 7x cubed, right? Or 7x to the third. Got that. What's next? Squared. 4, 3, 2. So plus 4x squared. 1. We don't have a 1. That's okay. There's a hole, and that's okay. The last term is a constant, and that's our minus 2. Okay? So we covered a lot today. We covered everything I think that we need for a little while. Okay, it'll help us start on Monday. Polynomials, what terms are. The terms, right, are separated by a plus or a minus sign, a positive or a negative. Okay, there's monomials, there's binomials, there's trinomials. All right, 3 things that make an expression not a polynomial, right? Those 3 things. The big thing to remember is that the variable can't be in the denominator. There's no division by a variable for a polynomial, okay? And that radical sign. You see that it's a big red flag. The degrees of polynomials, right? Determined by the exponent of the variable. So this is a 3rd degree polynomial. We talked about what the degree of a constant is. It's always 0. Okay, and then this, we talked about how polynomials must be written in descending order of degrees. So we rewrote this example into descending order. Now, here's a question. Talking about the degrees of a polynomial. Okay, so the degree of the polynomial down here, what is the degree of this? And how many terms do we have, right? So we had terms. We have 1 term. We have 2 terms, we have 3 terms, and we have 4 terms. I gotta keep that negative sign with that term. So this is a 4-term polynomial. This doesn't have a special name. This isn't a monomial. This isn't a binomial. This is not a trinomial. Above 3, they're just called polynomials. Okay, so I'm gonna write here 4 terms. And what degree is it? Remember, we call it by its highest degree. So this is a 4th degree polynomial. Okay, so we may or may not have one more video notes lesson that talks about combining. I think actually I'll probably do it on the whiteboard, but that's where we're going. Okay, so I know this is a lot and it's a lot of writing, but it's really going to help you guys moving forward. And I really, really, really want you guys to work on understanding this. Do your best to just really go over it and to study it, and not only just to write it, but study it. Quiz yourself, right? Have somebody in your family or have somebody write these down, or get online and look through these things so that you can see the different terms here and how to put them in order and different things. Google search polynomials, how to add polynomials. Tell me what you find, all right? I hope you guys are doing well. I miss you tons. Love you lots, and I hope that you guys are able to find some, find some joy in the craziness of everything, okay? So, miss you much. Talk to you soon.